probability of E into probability of F, right? And we were doing few problems also. Similarly, when you have three events, probability of A intersection B intersection C is equal to probability of A into probability of B into probability of C, provided A intersection B is equal to probability of A into probability of B. That is, A and B should be independent, A and C should be independent, and B and C should be pairwise independent. If they are pairwise independent, then probability of A intersection B intersection C is probability of A into probability of B into probability of C. We were also doing few problems, right? So how many problems got over? Till 11th, example number 11th is what we did. We'll do few more problems and we'll go to the next topic. 3 coins are tossed simultaneously. Okay. Just give me a minute. Just a minute, guys. So 3 coins are tossed simultaneously. Consider the event E, where 3 heads or event E is about the 3 heads or 3 tails. Event F, at least 2 heads. G, at most 2 heads. Of the pairs E and F, E, G, F, G, which are independent and which are dependent. So let's try to calculate. So sample space is what? How many elements does it contain? Sample space contains 8 elements. What are the 8? So you know, right? 2 power 3 elements. HH, TT, TT, HH, TT, HH, TT, HT, 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 HT. Right? So these are all the outputs. So event E is about getting 3 heads. So 3 heads means head, hit, or tail, tail. So H, or tail, tail. What is event F? At least 2 heads. So at least 2 heads means it can be HHT, HTH, THH, and HHH. Right. So event G is about what? At most 2 heads. So at most 2 heads means head, tail, head, tail, head. Now they are asking which of the pairs is independent. So what is the probability of E, guys?
2.
How can it be 2? Probability of 2, E. 2 out of 8. It is 1 by 4. So what is the probability of F? 4 by 8, that is 50%. So probability of G is 3 by 8.
Sir?
Right? Yeah, tell me.
Sir, in G it can also become no, sir, HTT.
No, but what did they say? At most 2 heads, no? At most means. So at most means minimum can be 1 head also, right? Yeah, that's right. So it should be HTT, right? So HHT, HTT. Yeah, HT or TTH, anything. Right, that is you're telling about the seventh one. That's right. Yeah, because at most means I missed it. So it will be 4 out of 8.
So then TTT
No.
also.
Wait. It's not 4 out of 8 then. Then except the last one, everything else is possible. So all these things are possible. At most 2 heads. No, except this one, all the 7 are possible. That's right. Yeah, sorry, I missed it. So it should
But
be
sir, at most means maximum 2 heads, no sir.
maximum 2 heads. It can minimum can be 0 also.
Then H won't come, no sir.
No, it won't come. That's why I cancelled it. No, except this one, all the 7 will come. So TTT, TTH, everything else will come till HHT. So you will have 7 outputs. So except HHH, you have to write everything. So probability of G is 7 by 8. Now is it fine? Yeah. So they're asking which of the pairs is independent. So what is the probability of E intersection F? So E intersection F, what are the elements that you have? HHH, HHH, TTT is not there. So probability of E intersection F is 1 by 8, right? So what is the probability of E intersection G? So how many elements are common in E and G? For that I have to write everything. So HHH and TTT. So there also one element is only common. So 1 out of 8. So what is the probability of F intersection G? Is there anyone who's not clear with what I'm doing? So what is the probability of F intersection G? What are all the elements that are going to match? Except HHH, there will be 3 elements which are matching, right? So it will be 3 out of 8. Now you guys tell me which is independent. So probability of E intersection F is 1 by 8. So what is the probability of E into probability of F? One by 8. So E and F are independent. Guys are able to understand because probability of E intersection F is equal to probability of E into probability of F. So what is the probability of F into probability of G?
Seven by 16.
Is it independent?
Dependent.
No, sir.
They are dependent. What about probability of E into probability of G? That is 7 by 32. So similarly, E and G are also dependent. So what is the only one which is independent? It is E and F. Guys, I hope you're able to understand. So what we did is we found the individual properties. We found the probability for the intersection. We verified if the probability of intersection is equal to the individual products. If it is equal, then it is independent, else it is not.
So can you show the sum, sir?
I hope it is clear, right? Done?
Yes, sir.
Okay. So let's do the next one. So this, let's see. Prove that, comma, if E and F are independent events, then so are the events E and F dash. So what is given? E and F are independent. So probability of E intersection F will be equal to probability of E into probability of F. So what can you say about what is to be proven? Probability of E intersection F dash should be equal to probability of E into probability of F dash. This is what we need to prove, right? So how do we proceed? Now let's think of it. So you have a universal set, right? So in this universal set, we can think of two events, E and F. Okay. So let's say this event is E, this event is F. So what is probability of E? So tell me one thing. If this whole circle, the first circle is completely E, then I'll mark a region. You guys tell me what it means. What does this region mean?
E minus F.
Yes. So it is E minus F. Can you tell me in terms of intersection and all? So E minus F means E is happening and F is not happening. Can I write it like that? Similarly, what will this region be, guys? The one which I'm shading on the right.
F intersection E dash.
So this is F is happening and E is not happening. So the intersection one is obviously E intersection F. So they're asking probability of E intersection F dash. So how do I write it in terms of set? See, what I'm going to do is number of elements in E intersection F dash. Can you tell me in terms of E and F so that we'll have an understanding? So can I write it as number of elements in E minus the number of elements in E intersection F accepted? Did you understand what I did? So look at it like an area. So the number of elements that are present in E intersection F dash is equal to the number of elements that are there in E minus the number of elements that are there in the intersection. So if I divide with sample space on both sides, if I divide with n of s on both sides, what do I get? Probability of E intersection F dash is equal to probability of E minus probability of E intersection F. Accepted? But what is probability of E intersection F? It is probability of E minus probability of E into probability of F. So what can I take out common? Probability of E into 1 minus probability of F. What is 1 minus probability of F? That is probability of F dash. Did we prove? Did you guys understand what I did?
Yes, sir.
So make a note of it. See, if you are thorough with this concept of probability, you need not do this step actually. You can directly start from this step. Okay, shall I move on? Now see. Example 14. If A and B are two independent events, solution. So wherever you see independent event, probability of A intersection B is equal to probability of A into probability of B. This is given. So let this be equation number 1. Then the probability of occurrence of at least one of A and B is given by, then we have to Are we supposed to prove that? So are they asking us to prove if A and B are two independent events, then probably. Okay, assume they're asking us to prove. So at least one of A and B. So at least one of A and B means what? So at least one of A and B means what kind of an operation are we going to perform? So if I write A intersection B, what does it mean? If I ask
A
you to
and
write
B.
A and B is happening here, at least one of A and B means A can happen or B can happen. Can I write it like this? So to prove what probability of A or B is happening is 1 minus probability of A dash into probability of B dash. This has to be proved from where? From the given condition. So how do we proceed? So probability of A union B is equal to what? From the addition theorem of probability, because see 1 minus I need PA dash. PA dash can be obtained as 1 minus probability of A. PB dash is obtained as 1 minus probability of B. So we'll write it in terms of probability of A and probability of B. So probability of A plus probability of B minus probability of A intersection B. Accepted. But what is probability of A intersection B? Probability of A into probability of B. Now what you need to do is you need to factorize. So in these two, I get probability of A as common thing into 1 minus probability of B plus you're left out with probability of B. Right? Now what can we do? So probability of A, there is nowhere A, right? What is to be proven? A dash, right? So probability of A into, what can I write this as? This is probability of B dash plus probability of B. Did I leave anything? Now let's see. So probability of A, I can write it as 1 minus probability of A dash into, here you have probability of B dash plus probability of B is 1 minus probability of B dash. So let's multiply. So probability of B dash minus probability of A dash into probability of B dash plus 1 minus probability of B dash. Is there anything that gets cancelled? B dash is gone. So we are left out with 1 minus probability of A dash into probability of B dash. So this is the proof. Is there any doubt?
No, sir.
Okay. Shall I proceed to the next question?
Yes, sir.
Okay, with these examples are over. Now let's do a few exercise problems. So probability of A is 3 by 5, probability of B is 1 by 5. Probability of A intersection B, A and B are independent events. So probability of A intersection B is, directly tell me, 3 divided by
25.
25. Because they are independent. Right. Next. You guys read the second question. Tell me how we are supposed to do. So how to do, guys? Two cards are drawn at random and without replacement, okay, from a pack of 52 playing cards. Find the probability that both the cards are black. So how to do? How do you define the events? What are the two events that we need to take into consideration? So let's say I'm defining event A and B. What is event A? So how many cards are drawn? Two cards are drawn. So what will be the first event? They're asking what is the probability that both the cards are black. Means A is first card is black.
Black.
What about B? Second card is also black, provided
Without any
here it is
replacement.
without replacement. This is important. So how many black cards are there? Total black cards are
26.
so total black cards are 26. Total cards 52. So what is the probability of A?
26 by 52.
Yes. So probability of A is 26 by 52. What is the probability of B?
25 by 51.
Yes. Now what can you say about probability of getting both as black cards?
A intersection B.
So it is probability of A, that is 26 by 52 into 25 by 51. How much is that? So 26 by 52 is 1 by 2. So 25 divided by 102. That's the answer. So here, why I multiplied is, they told both the cards are black, right? These are subsequent process. So wherever the subsequent processes are happening, you have to multiply them. So remember, in most of the places, if it is AND operation, okay, then it will be multiplication. If we do OR operation, then it is addition. So these are all the keywords, okay? So AND means multiplication, OR means addition. Similarly, most of the cases intersection is multiplication, because intersection is and union means addition. So have it in your mind. Next, third one. A box of oranges is inspected by examining 3 randomly selected oranges drawn without replacement. If all the 3 oranges are good, the box is approved for sale. Otherwise, it is rejected. Find the probability that the box containing 15 oranges, out of which 12 are good and 3 are bad ones, will be approved for sale. So how to proceed? So how many events should I define? So sample space contains 15 elements. Okay. So there is an event where 12 are good and there is an event where 3 are bad. So when will it cut? If all the 3 oranges are good, then the box is approved. Okay. So here, how many oranges? 3 oranges are selected. They are selected. Read the question carefully. They are not selected at the same time. They are selected one after the other. Okay. So how many events should I define, guys? How many events should I define? A, B, and C are events of first, second, and third draw of what apple. Here, what is to be? You need to approve it. third draw of how many apples? Sorry, oranges. Am I right? So in this case, then what will be the probability of A?
12 by 15.
That's right. So what will be the probability of B? That is in the second draw without replacement, you're trying to draw a good orange. So how many oranges are left out? 14 oranges are left out. Out of those 14 oranges, how many good oranges are left out?
11.
11.
Similarly, what is the probability of C? Now you are left out with 13. Out of those 13, how many good oranges are? 10,
And
right? So what is the probability that it will get approved? So probability of getting approved is probability of A should happen and probability of B should happen and probability of C. I just now I told you and means multiplication. 12 divided by 15 into 11 divided by 14 into 10 divided by 13. This would be the answer. How much ever it is, you calculate it. But I hope the concept and thought process is clear. Right. So moving on. Next. A fair coin and an unbiased die are tossed. Okay. Let A be the event where head appears on the coin. So solution, they have given the events. A is head appears on the coin. What is event B? 3 on the die. Check whether A and B are independent events or not. So what is the probability of A? So but here I need to write properly, right? So fair coin and an unbiased die. So both are happening simultaneously. So what will be the sample space, guys? So head can come along with 1 on the die. Head can come along with 2 on the die. Head can come along with 3 on the die. Like this, it keeps on going till h comma 6. Similarly, tail can come 1 on the die. Tail can come 2 on the die. Tail comma 3 till where? Tail comma 6. So sample space contains 12 elements. So A is head appears on the coin. Okay. So event A is head appears on the coin. So h1, h2, so on till h comma 6. Event B is what? 3 appears on the die. So h comma 3 and
T comma 3.
t comma 3. These are the possibilities. So what is the probability of A?
6 by 2.
6 by 12.
6 by 12. That is 1 by 2. What is the probability of B? 2 by 12. That is 1 by 6. So what is the probability of A intersection B?
2 by
So
12.
A and B has only one thing common.
1
That
by
is,
12, sir.
that's right. So 1 by 12. So what is probability of A into probability of B? That is 1 by 2 into 1 by 6. 1 by 12. Are they independent, guys?
Yes, sir.
Yes. Okay, we'll do 2 more problems, then I'll explain Bayes' theorem. Shall I move on?
1 minute.
Yeah, right.
Yes, sir. Done.
Yeah. First one. A die marked 1, 2, 3 in red and 4, 5, 6 in green is tossed. Let A be the event that the number is even. So what is the sample space? 1, 2, 3, 4, 5, 6. There is only one die. So event A is what? Event A is the number is even. So 2 comma 4 comma 6. Even B is the number is red. Red means 4, 1, 2, 3.
1, 2, 3, sir.
Yeah. 1, 2, 3. A and B are A and B independent. So what is the probability of A, guys? I think it's a simple problem. It is 1 by 6. Sorry, 3 by 6. So what is the probability of B? That is also 3 by 6. What is the probability of A intersection B?
1 by 6.
What is common?
2.
So it is 1 by 6. So probability of A into probability of B is how much? It is 3 divided by 12. So they are not independent.
Sir, is it 1 by 4, sir?
Why is it 1 by 4?
Probability of A into B, sir.
Oh, 1 by 2 into 1 by 2. 1 by 4, right? Sorry. So it is 1 by 2. So 1 by 4, right? Yeah. 1 by 4. Still it is not independent, right? Here it is. Yeah, it is not. Okay. One last problem. Let E and F be events such that probability of E is 3 by 5, probability of F is 3 by 10, probability of E intersection F is 1 by 5. Are E and F independent? Without a doubt,
Not independent.
Not independent.
this have to multiply. So it is 3 by 50 and probability of E intersection F is 1 by 5. So no. Okay, till now we didn't do any exclusive based problem, right? So what is the difference between exclusive and independent? So if events are exclusive, then A intersection B is null set, right? So from this, we can say that the probability of A intersection B is 0. Under what scenario? If the events are mutually exclusive, right? Whereas if the events are independent, then the probability of A intersection B will be product of individual probabilities. So probability of A is 1 by 2. Probability of A union B is 3 by 5. So probability of B is P. Find P if they are mutually exclusive. So solution, first one. So wherever they have given you probability of A union B, there is one formula. What is it? Probability of A plus probability of B minus probability of A intersection B. But probability of A intersection B is 0. The case of mutually exclusive. So probability of A union B is 3 by 5 is equal to probability of A is 1 by 2 plus P. So what is the value of P, guys? 3 by 5 minus half. 0.6 minus 0.5. 0.1. It is 1 by 10. Right. Second, what about them being independent? So probability of A intersection B is equal to probability of A into probability of B. So 3 by 5. Oh, we don't know A intersection B here. So probability of A intersection B can be written as probability of A plus probability of B minus probability of A union B is equal to P of A into P of B. Guys, did you understand what I did on the left hand side? I used the addition theorem of probability. We know that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B, right? I took it this side and A union B to the other side. So what is probability of A? Half plus probability of B is P minus 3 by 5 is equal to probability of A is half and here you have a P. So 1 by 2 minus 3 by 5 is minus 1 by 10 is equal to minus P by 2, which implies P is equal to so I hope this is clear.
Yes, sir.
Okay. So with this, we have completed 7 problems. I think 14 more problems are there. Right. So all these things you can try as homework. And the next class, if you have any doubts, you can get it clarified. Okay. So we will go to the next topic and the important one, which is Bayes' theorem. So write down a theorem called Bayes' theorem. Okay. So I will directly give you the formula and I'll tell you when you are supposed to apply this, why this theorem has actually come into picture. So this theorem of total probability and all is not needed. So the Bayes' theorem statement goes like this. If you have n events, that is events E1, E2, so on till En, if these are non-empty events which constitute a partition of the sample space, means these are all part of a sample space such that they should follow two important conditions. Please make a note. I'm repeating it. If the events E1, E2, E till En are n non-empty events which constitute a partition of the sample space, and if E1, E2, so on till En are pairwise disjoint, what is the meaning of this? So which events are actually pairwise disjoint? So here, all the events, so for you to apply Bayes' theorem, you need to ensure that all the events, all the n events that you're considering should be mutually exclusive, and E1 union, E2 union, so on till En is equal to sample space. What are the name of these events? So what do you mean by the union of all the events put together is equal to the sample space? Forgot so soon. They're called exhaustive events. So what are the probability of mutually exclusive events? So what are the probability of mutually exclusive events? Guys, are you there? Am I audible?
Yes.
So tell me, what are the probability of mutually exclusive events?
0.
Null set.
0. No, null set is the intersection. Probability is 0. Probability cannot be equated to set, no? Similarly, what is the probability of exhaustive events? Exhaustive means what? You're making use of all. So probability of exhaustive events is 1. Probability of mutually exclusive is 0. Have this in your mind, okay? So I'm repeating the statement. Listen. Bayes' theorem, these are all the conditions. If you have n non-empty events, which are a part of the sample space, all the n events are part of the sample space such that all the events E1 to En are pairwise disjoint, means they are mutually exclusive and they are exhaustive as well. Okay, and exhaustive as well. And A is any event of non-zero probability. Make a note of it. And A is any event which is having a non-zero probability. Then probability of any event, it can be E1, E2, anything. Probability of any event E with respect to A, that is given A is equal to probability of EI into probability of A given EI divided by sum of probability of EJ. You write the same pattern, okay, into probability of A given EJ, where J is going to vary from 1 to n. don't worry about all these formulas. I will tell you how to apply it. I'll tell you how to collect the data, how you are supposed to approach. Ensure you write it and focus on the important points I'm stressing upon. I hope you have written it.
So 1 minute, sir.
Yeah, write it.
Done, sir.
Done. Okay. So now we need to, well, let's look at an example. I'll tell you how to collect the data and all those things. So let's take this example. One minute. Yeah. So look at the 16th one. Now read this question. So there is a bag one which contains 3 red and 4 black balls. So there is bag one which contains 7 balls. While another bag B2 contains 5 red and 6 black balls. Okay. One ball is drawn at random from one of the bags and it is found to be red. Find the probability that it was drawn from bag 2. Okay. So if you read this question, they have given information, they have asked some probability, but we need to understand and define the events properly. Okay. So let's read the question carefully. Bag 1 contains 3 red and 4 black balls, right? And bag 2 contains 5 red and 6 black balls. One ball is drawn at random from one of the bags and it is found to be red. Okay. Find the probability that it is drawn from bag 2. Here, if you observe this part of the statement, is this clear? If you look at the second statement, the second sentence that is there, one ball is drawn at random from one of the bags and it is found to be red. Okay. So now we have to check, is red ball available in both the bags? Yes, it is there. So how are we sure that it is only drawn from bag 2? We don't know, right? So we need to define certain events. So the second statement is going to give us the events, right? So logically tell me guys, even before you select a red ball, what is it you need to select first?
Bags.
You need to select the bag first. So solution is, so always give the symbols E1, E2, so on for the events and A for the condition. Okay. So E1 is what? Selecting bag 1. Can I say like this? So E2 is the event of selecting bag 2. Then what is event A? So probability that, so what is the event A? It is found to be a red ball. So red ball is the specific event that we need. So event A is about selecting a red ball. Now tell me one thing. Look at the events E1 and E2. Are they mutually exclusive? Are they mutually exclusive? That is E1 intersection E2. It's a null set, right? Because selecting bag 1 is completely different from selecting bag 2. Similarly, E1 union E2, is it equal to the sample space? That is it completing? Is it an exhaustive event?
Yes, sir.
Yes, sir.
It's 100%, right? So when these two are satisfied and A is selecting a red ball, look at the question. Though they're asking, what is the probability that the ball is drawn from a second bag? So what is the probability of getting? What is the probability of selecting a second bag, known that it is a red ball? That is the meaning. So here they're asking, what is the probability that it was drawn from bag 2? So what is the probability that you have selected bag 2, given that you need a red ball? That is the meaning. So probability of E2 given A, according to the formula, what is it? It is probability of E2 into probability of A given E2. Because what is the formula? We have written it now. EI by A, EI given A is equal to probability of EI into probability of A given EI divided by probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. So our work is to find all these things. So what is that we need? We need probability of E2 given A. So for us to find probability of E2 given A, it is dependent on these many parameters, right? Let's write down each probability. So what is the probability of E2? What is the probability of
By 2.
selecting 1 by 2? What is the probability of E1?
Sir,
1
how
by
it
2.
is 1 by 2?
Because 2 bags are there, out of which you are selecting 1 bag. See, when I say probability of E2, read the statement, selecting bag 2. In how many ways you can select either of the bags? 50-50 chances, right? So 1 by 2. So probability of E1 is also 1 by 2 accepted. 1 bag out of the 2 available bags. So what is the probability of A given E1? That is, try to understand. What is the probability of getting a red ball known that it has come from the first bag? So what is the probability of getting a red ball from the first bag, guys?
3 by 7.
3 by
Very good.
7.
So what is the probability of getting a red ball from the second bag?
5 by
5 by
7.
11.
Of
11. Take all these values, substitute here, that will give you the answer. Okay, that calculation part you do it later. Calculation part you do it later. Let's do a few more problems so that you get grip on this particular topic. I'm moving on. Shall I?
Yes, sir.
Okay. Now let's look at the 17th one, guys. So example 17, let's read the question. Given 3 identical boxes, when they say identical boxes, each box is going to have the same amount of probability, each containing 2 points. In box 1, both the coins are gold coins. In box 2, both are silver coins. In box 3, there is 1 gold and 1 silver coin. So a person chooses a box at random and takes out a coin. If the coin is gold, what is the probability that the other coin in the box is also of gold? Okay. So what are all the events, guys? So we need to understand the question. Read it again. So box 1 contains 2 gold coins, box 2 contains 2 silver coin, and box 3 there is 1 gold and 1 silver coin. So there is a person who chooses a box at random and takes out a coin. So while doing that experiment, he observes that if the coin is of gold, okay, he is clear that the coin is gold. What is the probability that the other coin in the other box is also of gold? So what are the events here? What are all the events? First event is what actually?
First box.
Selecting box 1. So I'll directly write it here. What is the probability of E1?
1 by 3.
1 by
1 by 3. So probability of E1 is 1 by 3. So E2 is selecting box number 2. So probability of E2 is also 1 by 3. E3 is selecting box 3. So probability of E3 is also 1 by 2. So A is the event where the condition is being implied. What is A? A person chooses a box at random and takes out a coin. If the coin is gold, so event A is getting gold coin. Then what is the probability that, see, look at the way I'm converting the statement. What is the probability that the other coin in the box is also of gold? So indirectly, what are they asking? Probability that you have chosen the first box, because indirectly what the other coin is also gold is possible in which box?
First box.
First box. So they are asking what is the probability that you have selected the first box and it is a gold coin. Known it's a gold coin. So this will be nothing but probability of E1 into probability of A given E1 divided by probability of E1 into probability of A given E1. You tell me guys, probability of E2 into probability of
A by E2.
A given E2 plus probability of E3 into probability of A given E3. So what is the probability of E1? So E1, E2, E3 we have written. So what is the probability of A given E1? So meaning of it, what is the probability that you have selected a gold coin known that it is from the first bag? How much is it?
2 by 2.
That is 100% chance, 1. So what is the probability of A given E2? Probability of getting a gold coin from the second bag?
0.
0. So probability of A given E3 is how much?
1 by 2.
1 by 2. Take all the values, substitute, you will get the answer. Take all these values and substitute it here. Okay, shall I move on?
Yes, sir.
Now look at the 18th. Suppose that the reliability of HIV test is specified as follows. Of people having HIV, 90% of the tests detect the disease, but 10% go undetected. Okay, so if there are 100 people who are having HIV, 90% of the tests detect the disease, but 10% go undetected. Of people free of HIV, 99% of the tests are judged HIV negative, but 1% are diagnosed as showing HIV positive. Means if 100 people are there, there is a possibility of 1% getting an error saying that the person is HIV positive in spite of not having it. From a large population of which only 0.1% have HIV, okay, from a large population in which only 0.1% have HIV, one person is selected at random given the HIV test is given the HIV test and the pathologist reports of him or her as HIV positive. What is the probability that the person actually has HIV? Here, what are all the events? So here the whole story is about what? About people having HIV. So with respect to people having HIV, what are the two conditions that are possible?
positive, negative.
It can the person can actually have HIV, the person can not have HIV. So event 1B of a person having HIV. E2B what? Person without HIV. Okay, what is A? What is the event that needs to be associated? So in the whole population, E1 and E2 put together, they are mutually exclusive, because if a person has HIV, then he cannot be in set E2. Similarly, the vice versa. What about E1 union E2? That is the whole population. That is the sample space. So E1 and E2 are events such that they are mutually exclusive and exhaustive. What is event A? One person is selected at random given the HIV test, and the pathologist reports as HIV positive. What is the probability that the person actually has HIV? So event A is what? So event A means person should have HIV. Okay. So what is the probability? So this person having HIV should come from which set? Is it like the person should not have HIV, but the test should show positive, or he or she should actually have HIV and the test should show positive? Guys, I try to simplify this question. See, this is very big actually. Okay. So what they have told us, there is a place. Okay, there is an area. Let's assume like this. There is an area where there are 1,000 people or 100 people. Let's take it for simplicity. In those 100 people, what they are doing is they are doing a test of what? HIV. So in the test, what is happening? The people who have disease, okay, people who actually have HIV, 90% of the test is success, but the 10% who undetected. Okay. Similarly, what is happening is, of people free of HIV, actually person who does not have HIV, the test is showing 99% correct result, but 1% there is a defect that can occur. Is diagnosed as showing HIV positive in spite of not having. So from such a large population, of which only there is only 0.1% people who have HIV, they are selecting one random person. Okay. So from such a huge population, out of the 0.1 having HIV, that is, they will have a test report, right? In the test report, they are taking the names of people who have actually tested positive. But here, try to understand, the test is not 100% accurate, because there is one person who is actually not having HIV, but being detected as positive. Are you able to understand? So out of that 1%, out of the 1% that you have chosen from the 0.1%, what is the possibility? What is the probability that the person is actually having HIV and he is also detected with a positive sign? So event A is the person should have HIV, and event E1 is what? Is actually having HIV. So it should be probability of E1 given A. So what is the probability of E1 given A? It is probability of E1 into probability of A given E1 divided by probability of E2 into probability of A given E2 plus probability of, E1 into A given E1 into probability of E2 into probability of A given E2. Now, how to take the data, guys? What is the probability of E1? So E1 means having HIV positive. How many people are actually having HIV positive? So what percent is actually having HIV positive? So from here you will get the data. From a large
90.
population, no. It is only 0. See, out of 100 people, only 0.1% has HIV. From a large population of which only 0.1 have HIV. So probability of E1 is nothing but 0.1 divided by 100. that is 0.001. Okay. What is the probability of E2 then? So probability of E2 means that person does not have HIV. There are no HIV patients at all. How much is it? 1 minus 0.001. It is going to be 0.999. So what is the meaning of probability of A given E1? So the meaning of this is probability of A given E1 means what is the probability of finding a HIV positive person, and he or she surely has HIV positive. For that only you have the data. Of people having HIV, 90% of the test detect no. So what is the probability that the person is having HIV and it is also detected as positive? It is 90 upon 100. It is 0.9. So what is the probability of A given E2? What is the probability of A given E2?
10 by 100.
10 by 100.
It is 10 by 100 because he is having but it is undetected. That is 0.1. Now you substitute all the values, you will get the answer. Oh, sorry, it is 1 by 100, right? So probability of A given E2 is because why is there 1%? Yeah. So what is the probability that he is detected positive, but he actually doesn't have? It is 1 out of 100, which is 0.0. Take all these values and substitute. You'll get the answer. Okay. So this question is one of the best examples for me to tell you where Bayes' theorem is applicable. So if you observe this particular question, right, because you might get a doubt when this comes in miscellaneous, how will I know whether I'm supposed to apply conditional probability or I need to go with Bayes' theorem? So the difference comes here. So conditional probability will have simple events. Whereas when you talk about Bayes' theorem, no, there will be a specific set of past. To be very specific, there will be a case study where it tells that this has already happened. Okay, for example, in this case of people having HIV, all these data is actually noted. It is known data, right? So all the data will actually be summarized, and they will ask you what is the probability of the future. That is, if a past is known to you, how will you predict the future? That is when this Bayes theorem comes into picture. For example, I'll give you the best example. Okay, let's say you're watching a cricket match. Okay, I think you guys can relate to it. So you're watching cricket match. Suppose in the 40th over, what is happening? So let's say there are 6 balls. So out of the 6 balls, what we are trying to do is we are trying to analyze the first ball. It is a 4. Second ball, it is a 4. Third ball is dot. Fourth ball is 6. Okay. So this is a simple example. So you have a specific set of data already. With the specific set of data that you have, will you be able to estimate a future? You will have a probability, right? See, probability itself is a guess. It's not 100% sure. So with the data already existing, if you are able to apply Bayes' theorem, then you can estimate what is going to happen in the next one. Are you guys able to understand? So with the data that you already have, we are actually trying to predict the future. So that's when Bayes' theorem is applicable. We'll see in the next example also. You'll understand it. Shall I proceed? See, there's a slightly tougher example, but I suggest you guys to try it again. So let's look at the 19th question. Here also, we'll speak about the data and then we'll speak about what is the prediction of the future. So there is a factory which manufactures bolts. So in that factory, there are 3 machines. So all the data will be given to you. There are 3 machines, A, B, and C, which manufacture respectively 25%, 35%, and 40% of the bolts. Observe 25 plus 35, how much is that? 60, 60 plus 40, 100%. So 100% manufacturing is taking place from where? From all the three missions. And each mission is going to produce a mutually exclusive output, right? So all the bolts are going to be different. They are not the same type of bolts. That's why you have three different missions. Of their outputs, so what they have observed is, let's say if the mission is producing, if mission A is producing 100 volts, out of those 100 volts, 5 volts or 5, yes, out of the 100 volts, 5 are five are found to be defective volts from which mission? From the mission A. That is actually happening on a regular pattern, 5% approximately here and there. So every time when the mission is producing 100 volts, 5 are observed to be defective pieces. That is a known information which that is an information already the factory knows. Okay. Similarly, the mission B, if it produces 100 volts, it is producing 4 defective ones. When the mission C is producing 100 volts, it is producing 2 defective ones. I hope you are able to understand this, guys. Right? Now, what they are doing is, so all those bolts have come into a box. Okay. Let's say the output of all the 3 machines are actually fed into a carton box like this. So now all the bolts have actually got mixed. So from mission A, you are getting, from mission B, you are getting, from mission C also you are getting. All the bolts are mixed here. So what is the data you have in your hand? So you know that 25% of the total bolts is produced by A, 35% is by B, and 40% is by C. Out of which, you know, in this lot, you will definitely have good ones and defective ones. Correct? Because the manufacturer already knows this. There are defective ones also that are getting produced. Now, what they are doing is, for the testing process, they are randomly selecting one bolt. A bolt is drawn at random from the product and is found to be defective. So, unfortunately, the one which he has picked is a defective one. What is the probability that the manufacturer, the picked one, is produced by mission B? That's what we need to find out. So I already have all the information in my hand. I'm just trying to predict that this has happened. So I'm trying to do the prediction. How is it possible? So for that, I need to define the events. So the events are supposed to be defined in what way? The events are supposed to be mutually exclusive and exhaustive. So E1 is bolt manufactured by whom? By mission A. So E2 will be what? Bolt manufactured by mission B. E3 is what? Bolt manufactured by mission C. Right? So a bolt is drawn at random from the product and is found to be defective. So event A is getting a defective bolt. So you know E1, E2, and E3, we are in all the 3 cases you have a defective bolt. So choosing a defective bolt is a case study here. So what is the probability that you know that you have picked a defective bolt, but what are they asking? That it has come from which mission?
B.
B means what is the event according to the symbol that we have given?
E2.
So this is what they asked. What is the probability that you have selected the defective piece from the mission 2? So it is probability of E1, E2 into probability of A given E2, the whole divided by probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2 plus probability of E3 into probability of A given E3. So what is the probability of E1, guys? So what is the probability of bolt getting manufactured by machine A, irrespective of whether it is defective or a good one? How many machines, how many bolts are getting generated? 25%. So probability of E1 is 1 by 4 because 25 by 100. What is the probability of E2?
35 by 100.
It is 35 by 100. So how much is this? 7 by 50 here? No, 7 by 20. What is the probability of E3?
2 by 5.
No, it is or 2 by 5. You told 40 by 100. It is 2 by 5. That's right. So what is the probability of A given E1? What is the meaning of this? What is the probability of selecting a defective well known that it has come from E1? Known that it has come from mission 1. So what is the probability of getting a defective bolt from machine 1? They have given, no, the numbers are given.
5%.
5%. So it is 5 out of 100%. So probability of defective bolt from the second one, from the second machine, that is 4 out of 100. What is the probability of getting a defective one from the third one? That is 2 out of 100. Now take all these values and substitute, you will get the answer.
Sir,
Tell me.
sir, how it is 5 by 100, sir? Is it 5 by 1 by 4?
It is 5%. No? They told 5%. No?
Okay, sir.
Yeah. Okay. One last problem and we'll wind up this session. So doctor is to visit a patient. That's the story. From the past experience, okay, you already have data. It is known that the probabilities that he will come by train, bus, scooter, or other means of transport are respectively 3 out of 10, 1 by 10, 1 by 10, and 2 by 5. Means if he has come 10 times to the patient's place, out of the 10 times, he has come 3 times by train, 2 times by bus, 1 time by scooter, and by other means, whatever number of times. So the probability is that he will be late. So during all these process, there is a probability that he will be late. So how much is the probability? It is 1 by 4 if he comes by train, 1 by 3 if he comes by bus, 1 by 12 if he comes by scooter respectively. But if he comes by other means of transport, then he will not be late at all. That's what has been observed. When he arrives to the patient's place, it is observed that he is late. What is the probability that he has come by train on that particular day? So what are the events? E1.
Train.
So coming by train. E2, bus. E3, scooter. E4, other means. So what is the probability of E1? It is 3 out of 10. Probability of E2, 1 by 5. Probability of E3, 1 by 10. Probability of E4, 2 by 5. Am I right? So 1 by 5 is 1 by 10. 2 by 5 is 4 by 10. Now add everything. 3 plus 1, 4. 4 plus 1, 5. 5, 3, 5.
Sir, it's 2 by 10. 1 by 4.
Yeah, 2 by, yeah, 2 by 10. So now it is coming, right? Now sum of all the probabilities put together is 1. So are they exhaustive events? And they are exclusive also because you cannot come by train and bus at the same time. So all are exclusive, right? So what is the event A here? What is the event that is associated with all this process? He is late. Okay. So what is the probability that he is late, known that he has come by train.
1 by 4.
What is the probability that he is late, known that he comes by bus? 1 by 3. What is the probability that he is late, known he has come by scooter? It is 1 by 12. So what is the probability of A given E4?
0.
0. Now what are they asking? What is the probability? So he is late. So known that he is late, what is the probability that he comes by train? What is the probability that he has come by train, known that he is late? So it is probability of A into probability of A given E1 divided by probability of, sorry. Probability of E1 into, so probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2, then probability of E3 into probability of E given A3, sorry, A given E3, and lastly probability of E4 into probability of A given E4. Did we find all these values? We have the data for everything. Our work is only to substitute it here and get the answer. To some extent, are you guys clear with what I'm doing? You understood when to apply base,
Yes, sir.
Yes, sir.
right? So we'll do a few more problems in next class. Don't worry about it. So the previous exercise alone, I want you guys to try it. Okay. So with this, actually, the chapter is over. We have to only sit and work on problems. So don't leave. Wait for a minute.